In this lesson, we're going to take a look at solving compound inequalities. So first, let's start out with the definition. What exactly is a compound inequality? Well, it is an inequality formed by joining two inequalities using either and or or. Now, a little bit of English here. The word and means that we are including something. So if it says and, both characteristics have to be met at the same time. So, or gives us a choice. This shows that either one condition or the other will be met, but not both at the same time. So, let's take a look at some examples of compound inequalities. If I were to say x is greater than or equal to 2, so on my number line, if I have 2 here, I'm going to the right. Then I take x is less than 5. So at 5, I'm going to the left. I can combine these by saying x is greater than or equal to 2 and x is less than 5. So now on my number line, I have 2 and I have 5. I'm not including 2. I am including 5. And it's everything in between those two spaces. Now, when we are dealing with a compound inequality that states and, you can actually make a single sentence out of it. Say x here, as you can see graphically, x is trapped between these two items. So I can trap it between that 2 and that 5 and make a single sentence out of it. Next, we could do it the other way. We could say x is less than or equal to 2. So we're here going down. You say x is greater than 5. So that would be at 5 going up. And then I could put it together and say x is less than or equal to 2 or x is greater than 5. In which case on my number line, I have 2 and I have 5. From 5 I'm going up, from 2 I'm including it and going down. I have to meet either one or the other. There's no way for me to have both at the same time. And because these are separate items, we do have to take in consideration the fact that we can't write it as a single sentence. We have to write it out in its two pieces with or in between. For and, we do have that choice. What would something like this look like if we were to interpret it from an English sentence? So what if I were to say a number w is at least 6 and less than 15 2/3? So that means 6. Since I have this and as an option, I'm going to say that I can put my variable w in the middle. My boundaries are 6 on the low side, 15 2/3 on the high side. At least 6, that means it can be included, so less than or equal to. But less than, that means it is not included. So I have 6 is less than or equal to w, which is less than 15 2/3. Let's take a look at one other. And for this one, I'm going to use the written form rather than the Greek symbol, but a number q is below pi or above 5 pi. So we're going to have an or situation in here, as stated. So I have to write it as two separate items, so or. Now q is below pi, so q is less than pi, or it's above 5 pi, so q is above 5 pi. So we can have different situations where we are including on one end, including on both ends, or not including on both ends. And then we get the different situations you see modeled here. So let's take a look at how to solve some of these compound inequalities. Our first one, 5 is less than x plus 7, which is less than 18. Now this looks a little different than what you're used to, But with a compound inequality, we can write it as a single sentence, so we have our and situation here all put together. And if you remember our addition or subtraction properties of inequalities, it stated that if you subtract the same item, same value from each piece of an inequality, you maintain an equivalent inequality. So all we have here is 3 pieces, so as long as I work with all 3, I will be fine. So with my variable here trapped in the middle, x, I have addition, and I'm going to subtract 7 from all pieces of this inequality, and what I will get is negative 2 is less than x, which is less than 11. Now from a number line standpoint, I have negative 2 and I have 11. On both of these locations, I'm going to have an open circle, and I will include everything in between. So any number from negative 2 to positive 11, not including those endpoints, becomes a valid solution. So if I were to pick a number such as 2, which would end up right about here on my number line, 2 plus 7 is 9, and 5 is less than 9. 9 is less than 18, so that works. Next, we'll look at an OR situation. We have negative 2x plus 1 is greater than 9, or 3x is greater than 6 and 21/100ths. Here I'm going to have to solve this as if it were 2 separate items. So, solving the left hand, we're going to subtract 1 from each piece. Negative 2x is greater than 8. Then I'm going to divide by a negative 2, and I get x is less than a negative 4. Because remember, when you solve using by either multiplying or dividing by a negative number, you have to change the direction of your inequality. Other side, all I have going on is multiplication, so I'm going to divide each piece by 3, and I get x is greater than 2 and 7/100ths. So, if I get out my number line, I have negative 4 on the left, I have 2 and 7/100ths on the right, with 0 somewhere in the middle. I'm going to not include the 4, and I'm going below it, and I'm going to not include my 2 and 7/100ths, and I'm going above it. So anything that makes this true, anything to the left of negative 4 or to the right of 2 and 7/100ths will work. Well, let's pick a number that theoretically should not work. Let's pick 0. So, if I take 0 and substitute in here, negative 2 times 0 is 0. 0 plus 1 is 1. 1 is not greater than 9. If I substitute 0 in here, 3 times 0 is 0. 0 is not greater than 6 and 21/100ths. So I found something in the middle that did not work, and we figured that it should not. So now, what would this look like from a situation standpoint? Let's take a look at one such. A sleeping bag is rated for a nighttime low temperature of 0 Celsius and a high temperature of 15 degrees Celsius. What is this temperature range in Fahrenheit? Well, first, let's take a look at our situation. Our temperature of accepted ranges, it has to be above or equal to 0 Celsius, but below or equal to 15 Celsius. Now the question is, how do we go from Celsius into Fahrenheit? Well, our equation or conversion is C equals 5/9 of F minus 32. So if these temperatures are in Celsius and I need to make them Fahrenheit, I'm simply going to put this in where that T is located because that's my temperature conversion. So rewriting this, I get 0 is less than or equal to 5/9 of F minus 32, which has to be less than or equal to 15. So going through and solving this, I'm going to begin by multiplying all pieces by 9/5, because rather than dividing by the fraction 5/9, I'm going to multiply by its reciprocal. The far left-hand side, that's easy. I'm still going to come out with 0. It's less than or equal to F minus 32, which is less than or equal to 27. Now I'm going to add 32 to all pieces, and we come to find out that the sleeping bag has a Fahrenheit temperature range from 32 degrees Fahrenheit all the way up to 59 degrees Fahrenheit. So as long as the nighttime low temperature is between 32 and 59 degrees, including those endpoints, we will have a good time sleeping. So, situation we can look at and apply. So compound inequalities, same thing, just you have to get used to the idea of either solving two separate inequalities as a single item or having this chain inequality and including everything in between. So make sure you have this because we're going to need it moving into our next item, which will be absolute value inequalities.